Welcome to WTUFO. I hope you're enjoying watching or listening. If you'd like to support the show directly, you can do that at patreon.com/WTUFO, patreon.com/WTUFO. That will help increase the chances that the show continues to exist. If you're listening on a podcast player, you can also rate and review us. That'll help the algorithm know to tell other people about us. And likewise, if you're on YouTube, you can like and subscribe. And finally, if you're really digging it, you can post us on your favorite social or put us in a thread to your friends. Just kind of helping us spread the word, since we're a new show, is extremely useful and a valuable contribution to our mission. So thank you so much for engaging. I hope you enjoy the episode. What the UFO? I'm talking with Dr. Matthew Szydagis today. Matthew, it's great to meet you. Thank you so much for being here.
Happy to be here.
Thank you. I'm really excited for this conversation. Matthew is an associate professor in the Department of Physics at University at Albany, and he's a scientist with UAPx. Does that sound right as your title and your current career positioning?
Mm-hmm.
Okay, cool. I've also got your background as including a BA, an MS, and a PhD, all from University of Chicago. I'm curious, did you grow up in that area or just land in Chicago for school?
No, I grew up in Chicago. So then I decided to stay there, which is unusual because, most people will get degrees from different institutions in my field.
Okay. And in your career so far, you've been largely specializing in experimental astroparticle physics with a focus on detection of dark matter. Is that right?
That's correct.
Very cool. Fascinating subject. I'd love to hear a little bit about. And also for UFO purposes, we should mention you are a member of the science team on UAPx, where you helped conduct that organization's first UAP expedition. And you described your preliminary findings in a forthcoming paper, which we're going to talk about today. And people can also check out the documentary A Tear in the Sky, which followed this first expedition, and get a little bit of a sense of what it was like to go on that. So thank you so much for speaking with us, Matthew. Can you please just start by telling us a little bit about your background and interests in science generally?
Sure. I grew up watching Star Trek, The Next Generation. I'm a little too young for the original series. It wasn't on even in reruns. I had to watch it later, actually. Before streaming, I had to go find it, download it illegally. It's okay. I deleted it all since, or did I? Yeah, I did. It was years ago. But I watched Next Generation. Captain Picard, and also I watched Star Wars. I don't discriminate. Star Trek versus Star Wars, as well as there's so much else. Doctor Who, things like that. So huge fan of science fiction. And really, that's what turned me on to science. I really wanted to be Lieutenant Commander Data, the science officer on the Enterprise D in Next Generation.
Okay. Interesting character choice. Yeah, he had all the answers, I guess, Data.
Exactly. Just like Spock before him in the original series. Yeah.
Right. So you did TNG first, and then you went back to...
Yeah. Then I could catch up when I could find where to get it rented from the, you remember video stores like Blockbuster? They're like, there's like one left, I think, or two in the country. Yeah, no, I would rent episodes or I'd download when I could, and I would look, but that was challenging, and that came actually much later. So after Next Generation, I watched Star Trek Voyager. I never got into Deep Space Nine, but I did catch up on it later for completeness and realized that, it wasn't bad, but initially it didn't get into Deep Space Nine really. But Next Generation and Voyager, those were really the formative, television science fiction shows of my early years.
Cool. People still point to TNG as one of the greatest TV shows in history
ever made. Yeah, exactly. Yeah, and around the same time, I also watched, MacGyver, X-Files, Quantum Leap. And so these are really things, especially that really spoke to me. So like MacGyver, it was a physicist. Yes, he was secret agent and all these other things, but his degree was in physics, is the backstory, physics and chemistry. Okay. And so between all these different characters, Data, Sam Beckett, and all from these shows, even though they were fiction, they really turned me on to science.
Wow, cool. And so then when you got into the scientific arena, you started hunting the big game, and you've had this main activity centering around direct dark matter search. So you've collaborated, I don't even know how to pronounce this, but the Lux-Zeplin current generation multi-ton scale direct dark matter search experiment. Would you like to tell us a little bit about that and what it's been like to work on such a big project?
Yeah, I'm guessing that. Yeah, you read the words verbatim, but you're gonna need me to explain, right?
Yes,
It's just like the
I'm a
jargon.
layperson.
Yeah. So I'm as a high energy particle physicist, I often work on collaborations that have dozens, and in some cases, as an LZ, hundreds of scientists, of faculty, postdocs, students, engineers, technicians, that all work together towards a common goal of building usually a large scale experiment. And the LZ experiment is currently a world leading experiment looking for dark matter. There really isn't a sexy backstory of how I got into dark matter. You're saying I've been doing this for years, you just mentioned, but honestly, what happened is the professor at University of Chicago who was working on dark matter happened to be hiring. So there's no grand plan here. I could have done a different field of physics or particle physics or astrophysics or something. It was just who was hiring that day and who was sitting in their office when I knocked in 2005. And so
Okay.
there's really no, and really that's usually how it works in physics, at least, is your specialization may be accidental. Not always, there are people who know exactly what subspecialization they want to do, but I think that's rare. Just like it's rare for people to know exactly what they want to do when they jump into college. So I've been working on LZ and its predecessor Lux, and then before that on a different kind of dark matter experiment when I was at University of Chicago. So even though we think of dark matter astronomically, really I'm more of a particle physicist. I'm more hands-on. I'm experimental particle physicist. So I build detectors that will try to detect new particles, is probably the simplest and best way to put it.
Cool. That's very interesting. Well, to give people an image, I wanted to ask about the LZ equipment. And there's an underground facility, is that right? Like
Yes.
4,850 feet down in South Dakota?
That's correct. That's correct, because we need to get away from natural terrestrial and cosmic radiation. And so that's why sensitive dark matter experiments, they all have to find an underground site. And so we have one in South Dakota. It's the former site of the Homestake gold mine in Leeds, South Dakota, so nearly a mile underground.
Okay.
And basically, so we build a giant thermos of liquid xenon. You have to liquefy it, cold. And the reason why we use that particular element, xenon, it's got a lot of good chemical properties when it comes to radiation detection. And so it's one of the elements that is just a good particle detector in general. And so it forms the basis for one of the leading technologies in the search for dark matter. So we're just waiting for dark matter to come and make an interaction that we record as a flash of ultraviolet light and detect with ultraviolet photon sensors in the detector.
Okay. And is there any kind of similar experiment underway searching for dark energy, or would you be going about that an entirely different way?
No, completely different ways. It's apples and oranges. So
Okay.
Dark energy is typically done by astronomers, not by particle physicists. So the way we study dark energy is by looking at the accelerations of galaxies in the expanding universe. We look at dark matter that way as well. With telescopes, we look at dark matter, but dark matter also has this particle physics branch. Dark energy, not so much. There have been some attempts to do, earthly tabletop dark energy experiments, but they're less common. And part of that is because we really don't have a consensus theory or model that suggests that dark energy would be detectable terrestrially, whereas dark matter is probably a new particle that we can detect using the tools of particle physics. But yeah, in general, despite sharing the name dark, they're kind of apples and oranges, unrelated theoretically, and also have very different physical tools that we use in trying to understand them.
Okay. And so do you feel the weakly interacting massive particles are still the leading candidate for dark matter, that it's some kind of one of these WIMPs, a weakly interacting massive particle? Is that...
Yes, I think so, but it is getting troublesome how we've not made a discovery yet, a conclusive, unambiguous discovery. So there is some fear that the standard idea isn't quite right that was suggested in the 1980s and 90s in response to discoveries in the 70s with galaxies by Dr. Vera Rubin. So the basic paradigm there's definitely been some shaking in the faith, so to speak,
Mm.
but there's always the possibility that the probability of interaction of WIMPs is so low that it's just beyond our technological capabilities, at least right now. So they might be there, but they might have a cross section of interaction that's so low that could be why it's been so challenging to find any direct detection evidence. We've got all kinds of evidence from astronomy, but we don't have direct evidence in the laboratory.
Okay. And is anything coming out of CERN, Large Hadron Collider project, that could help in dark matter and dark energy research?
Yes, but it's very different than, for example, LZ that I work on. It's complementary. The approach of experiment I work on, LZ, is to try to detect, dark matter particles from outer space naturally occurring. But at the LHC, the approach is to create new particles. So dark matter could be discovered in an indirect sense that way. So the answer to your question is yes, but it's a very different approach. It's a complementary approach.
I see. Interesting. And so are you thinking currently, I'll get off this topic in a moment, but are you thinking it's a particle that we haven't yet cataloged? It's a particle that isn't yet in the standard model. Is that right?
That's definitely the case. If it is a particle and not something else, it cannot be a particle from the standard model. And the reason is because no standard model particle has all the correct properties in terms of interaction probabilities and mass and lifetime, things like that. So there doesn't seem to be a standard model particle that fits the bill. We've known that for quite some time. So it's going to have to be a particle from beyond the standard model of particle physics.
Cool. All right. Thank you for letting me exercise some curiosity there. Let's pivot. How did you get started in UAP studies?
So it's really a two-tier answer to that. Because first is sort of like the childhood aspect, going back to Star Trek, things like that. Because one of the other things I watched constantly was Unsolved Mysteries with Robert Stack. With the trench coat it sort of normalized the idea of UFOs for me, because you've got, murderer, rapist, kidnapper, UFOs, kidnapper, murderer, like, you know what I mean? It's like mixed in. And so it was interesting. It's a true crime show, but UFOs were in there. I mean, Unsolved Mysteries was true crime before that genre existed. It's like the first, or at least one of the first. And the way the show was done, they would mix in like UFOs as well as, like ghosts, aliens. They just threw it in.
Wow.
But they didn't treat it as like, oh, this is dumb. They treated it equally seriously to like human criminal stories. You know what I mean? And so that really was like had quite an impact on me, probably psychologically. But then obviously in academia, there's stigma, there's taboo. It's not treated seriously. So then there was like a revival within me, that came about through the everybody says this, I think nowadays, through Leslie Kean's New York Times article in 2017. She had a couple co-authors as well. Blumenthal and I think Cooper. I hope I get the names right. Yeah. So, but that completely changed everything. And Lou Elizondo coming out on TV. And I remember telling my wife, like, look, watch this. This is real. Like, they're just finally, there's some movement of disclosure. Look, X-Files was telling the truth. So like, and yeah, I watched X-Files, as well. That was later on. I watched it when I wasn't supposed to, when I was a little kid, like the gory, like monster stuff.
Yeah, it was pretty scary sometimes.
Yeah, it was. It was really scary. But also, Unsolved Mysteries was scary in a different way, because X-Files, even as a child, that's fiction. Yeah. It's meant to be entertainment. Unsolved Mysteries, you treat like, oh, this really happened, even if it really didn't, even if it's just hearsay. And so like, I remember some of the UFO-based episodes, like the Rendlesham Forest episode of Unsolved Mystery, scared the shit out of me when I was a kid. It's like this red orb moving through the forest, and and stuff, and so but it was really the December 2017 New York Times article, and my colleague Kevin Knuth, who also works on UAPx with me, who then talked up this article, and like I said, I saw Lou Elizondo on TV. And others, I saw Chris Mellon and stuff, and it started convincing me that, hey, and then I remembered all those Unsolved Mysteries episodes, and I was like, wait, maybe there is something something real here. Maybe there's something to this. It's not necessarily, doesn't have to be aliens, but it might be something new and interesting and something worth studying.
And so how did you scientifically start to approach it? Like, what were your scientific instincts about how to start investigating the subject?
Well, it wasn't really me in the driver's seat. It was really my colleague Kevin Knuth, who was really the thought leader, and really who like kind of like dragged me into this. And then somehow the UAPx people found him, and other organizations which we're members of as well, like SCU, Scientific Coalition for UAP Studies, which was founded after MUFON. So basically, is they found Kevin first, and then Kevin dragged me along because he's a colleague of mine in the physics department here. But my angle on things has been to bring some of the tools from my particle detection, because there are all these alleged cases of ionizing radiation from UAPs, and I thought that those are tools then that I could bring to the table, not exclusively, because again, you don't want to be like the boy with the hammer and everything's a nail. Not every UAP case has to have radiation, or ionizing radiation. But I wanted to bring my skill set and tools to the toolkit of the study of UAP. So that was sort of my approach, is to go to think about cameras sensors that weren't just cameras, and expand UAP studies beyond that.
That's really cool. And we're going to talk about this paper that you wrote and maybe get into some of those details of sensors and cameras. But I'd like to do something a little unusual here and center a subject that has become increasingly apparently important to me, which is funding for research like this. And I think that tends to show up at the end of these conversations. So I'm just going to pull it forward and ask for any takes that you have about this, because it's starting to seem to me like now that scientists like you and Dr. Knuth have a good idea of the kinds of sensor arrays that we need, and they're scientists in the Galileo project and citizen scientists like the Tedesco brothers doing that kind of work. Now that we have these kind of sensors, at least in early phases of development, and you've actually got some experimental data and experience, it seems like one of the big bottlenecks here is just the simple money. Like we need enough funding to get enough of these things built, that we can put them in enough places to, as you have noted, get some control data from like low UAP occurrence locations, and maybe get some active UAP hotspots recorded. So I was wondering what you think about the funding issue, and what steps you see your colleagues taking to address it, and if anything, what you think people from the community more generally can do to help you advance that project of getting more money for this research.
Yeah, lack of funding is an extremely problematic and serious issue. But I think I want to add a unique take on it based on what you just said. So it's not just, we need money for equipment. I mean, that would be nice, but there's another thing to consider, which is in academia. So what a lot of people don't know is professors aren't paid during the summer. You're only paid for your teaching responsibilities during the school year. So in order to basically survive, because our salaries aren't that much, pay the mortgage, things like that. Mm-hmm. Our research pays our summer salaries. So for example, I work on the LZ dark matter experiment that pays my summer salary. So, and also through grants, I can also pay students. I can get interns. I can get people who don't have to volunteer, but can actually get paid. So I think there's something that almost nobody's talking about. I'm talking about it. Most people talk about money for equipment. And I have I have a slight disagreement and a different approach, because in my opinion, I can take equipment I own right now, refurbish used equipment, camera, stuff like that. I need money for humans. My salary, student salary, because here's the problem. You gave me money for 100 cameras. Who's going to sit down and look at that data? And the answer is not like, we'll just AI, whatever. That's a cop-out, because you still need human eyes. You still need human eyes on data analysis. So who's going to train, for example, neural networks, things like that? You cannot remove the human element. Who's going to set up the equipment? Who's going to take the control data? You need to pay humans to do the work. So it's not as simple as, we'll just throw $1 million of equipment like that. It's worse than that. We need money for people. And so the approach that I am always saying is, look, just give people like me and Kevin just a tiny amount of money just to pay our summer salaries, pay some students. We will start with initial results with just the equipment we already managed to scrounge around, inherit for free or get used and stuff like that, because there's different approaches. Some people say, no, it's a terrible idea. You need the most expensive and best equipment. And I respectfully disagree. I think you want to get there. And eventually, absolutely, but you need a sugar daddy for that. You've got I think Avi Loeb has funding. At Harvard, he has got friends with good deep pockets, and that's really good. And he was able to get equipment. But in order to just start, we just need some seed funding so that I can, for example, step away from my other responsibilities. I cannot do so right now because they pay the bills. Like my LZ dark matter work is funded by the U.S. Department of Energy. And so the problem with funding also, it's multifaceted. As I said, you need persons and equipment and people. But what's really nice is people can be cheaper than equipment. Just like we need a little bit of money, a fraction of our yearly salary, just pay us during the summer. And that's cheap because professors don't make much. If literally someone came along tomorrow and had the number I'm going to tell you is laughably small. Someone could come along tomorrow and it is laughably small compared to what millionaires make, compared to what engineers make, full time, for example, versus scientists. Someone could come along and be like, Matthew, I've got $20,000 or $30,000. That's like nothing. That's like tiny compared. And I'll give you that per year. That's the cash flow, of course, per year. Drop all your other stuff. I would work on UFOs full time, 100%. And I would drop dark matter. I would drop all my other topics. All I need is 20 or 30,000 a year. That is laughably small, right?
Yeah.
Over the course of a year, that's like poverty line, because I would stay as a professor and that pays my 9 months salary. So I'm just looking for 3 months of salary. If someone listening today or listening to the hundreds of podcasts I've been on and said this over and over again is someone who's got, this amount of money is so small. It's like the spare change on Elon Musk or Jeff Bezos' nightstand, frankly, right? It's like 0.00001% of the Defense Department budget. Someone comes along and says, Matthew, I will give you $30,000 a year to pay you for the rest of your life to just work on UFOs. I would drop everything else and we would start getting answers. You double that amount and you get one of my colleagues. You triple it, you get 3 of us. You add a little bit more, we start getting equipment. But we can start with that small number and it'll be enough for people like someone like me or Kevin to drop everything else and just focus on just this topic, publish papers on this topic and everything. I mean, it amazes me. It's a trivially small number. Such a trivial amount of money. I mean, Galileo Project has millions. Such a trivial. You give me this money annually, and I will drop everything else and just work on UFOs. How can nobody do this yet? It just boggles the mind. And you ask, what can people do to help? People should write to their congressman, to their senator, and say there must be funding mechanisms put in place at the DOE, the NSF, at these 3-letter agencies and other numbers of letters, NASA. And there needs to be ways for somebody like me, Kevin, our colleague Cecilia, and all of us, people like Avi Loeb, people like Wes Waters, all these people working on this topic. We need mechanisms, funding instruments where we can apply officially to get money. So all the governance recently has been talk. There's been a lot of talk. Where are the requests for proposals to get funding? So the private foundations and private millionaires and billionaires have been stepping up and providing money for UAP studies. But here is the problem. There's so many organizations, nobody else who's to donate money to. We were trying to get money in UAPx, and our leader, Gary Varese, was told, he reached out to people. They said, sorry, I gave all my money already to SCU or Galileo Project or SUAP. So there's also a sort of a disharmony and maybe a lack of collaboration. And there are a lot of these silos where people have siloed themselves and created an acronym and created an organization, and they've got their UFO organization. And I've often joked that I'd like to create YAUFO, YAUFO, yet another UFO organizations. YAUFOO, because there's too many. There's too many organizations. And so people don't know who have spare money, who are interested in this topic, and they want to pay scientists. They don't know how to get the most bang for their buck because there's so much disunity in the UAP community, including among the scientists and engineers who are working on this. So that's sort of my long, I hope not too long-winded, but I tried to answer all 2 or 3 of sort of your sub-questions in there.
Yeah, that's fantastic. Thank you so much. Do you think it's the case that the institutions now are not ready for grants? Like if you were to write a grant to the National Science Foundation and say, I need $30,000 for summer research, they would just not have the sort of like infrastructure to grant you that request? Or like, does it need to come from the political side first for the Department of Energy and the National Science Foundation and NASA and other organizations to set up dedicated money? Or do you think scientists could be applying for open-ended funds?
No, that's a non-starter. There's no such thing as open-ended funds.
Okay.
And that differs by agency, but for example, the DOE, which is the Department of Energy, they would laugh their asses off and throw that right away into the garbage. I mean, they would laugh so hard. Like, it doesn't work that way. You need to request funding for an existing initiative, an existing, like, you don't do unsolicited proposals. Like, this isn't the 1950s anymore, where I'm sure you could get away with that as a physicist. Nowadays, like, you request funding from a particular program, from a particular program manager. There's no open-ended anything, and you'd need a pot of money that says this is for UFOs, and there's no such thing. Well, there is for like private, for like inside of the government, there's funding for like the Office of Aero and things like that. But there is no open funding mechanism where an academic at a university can go and be like, apply for money for UFOs. Yeah, an unsolicited proposal would be rejected so fast. Like, it wouldn't even be, no one would even read past the first line of the first page.
Yeah.
Like, that's a non-starter. And to be clear, it's not just because of the stigma. To be clear, I could have some great idea that's completely unrelated to UFOs, and it's not in a stigmatized field, but an unsolicited proposal, that is a non-starter as far as the federal government funding agencies is concerned. That's just not how the world works.
Okay, that is super useful to know, and I think it's useful for UFO fans to understand and onboard this information, because with regard to the government, I think people tend to focus really hard on disclosure and just transparency from the military, which is great. I would like to see more of that, but I think people aren't keyed in enough to the necessity to, as you said, write their representatives and request funding allocations from the National Science Foundation and the Department of Energy and NASA, specific programs to get money to scientists who are interested in researching this.
Yeah, I mean, and actually, people often wonder, does writing to your legislator work? It actually does sometimes. So, for example, back in the, I don't remember, it was 80s, maybe 90s, I think there was a huge campaign to sort of regulate vitamins and supplements. The FDA wanted to do that. And, and then there's a huge write-in campaign, like, don't regulate my vitamins and supplements. And there was even like a commercial with Mel Gibson where like Nazi style police or like a SWAT team comes in and it's like Mel Gibson holding vitamins. Like, it's just vitamins. It's like there was a whole public awareness campaign. And so basically, and there were senators like Orrin Hatch who were like, yeah, we're not doing this. So we need people who, like, enough people to not just fight for disclosure, because I'll be honest with you, I don't think you should hold your breath. You think the government is going to disclose anything it knows? My opinion is the right approach is this is going to anger a lot of people. But in my opinion, the right approach might be to almost even give up on trying to force disclosure. Just give money to scientists like me, Kevin, Cecilia here at University of Albany. Give money to scientists who will bypass disclosure because we'll get the evidence ourselves. Screw the government and the classified stuff. Now, I know there are a lot of people who disagree with me, and I respectfully have a difference of opinion with them. There are organizations, I know there's Nick Gold, there's the declassified UAP, and I'm not saying they shouldn't try, but I'm just saying don't hold your breath. Okay, I'm not convinced we're going to get government to disclose anything. So I think the right approach is again, I said a few minutes ago, maybe we should give up on that, but people are not going to want to do that, of course. But
Sure.
then don't put all your eggs in one basket. Then at the very least, could you please consider civilian scientists like me as plan B at the very least, and basically say, look, if we don't get disclosure, let's at least get money to people who can force disclosure by just actually getting our own evidence and getting so much evidence to the point where government's like, well, crap, we might as well say everything now because the civilians figured it out on their own with their own sensors already.
Can you help us understand how Fringe Science gets funding? Like, how did the Dark Energy Project get a whole bunch of funding? What was that, a multi-decade process of setting up these programs in the science funding institutions?
So that's an excellent question. So it really depends on how the degree of controversy surrounding an idea. So basically, part of the issue is that you need multiple independent groups. And so when I said earlier there are too many groups, I should clarify, I am by no means saying, oh, everybody should just merge into one group, because no, you do need healthy competition, collaboration, things like that. That's important. But I think you don't need 50 groups. You need 2 or 3. But there were 2 independent groups who also discovered the first evidence in the late 90s for dark energy. Okay. So multiple groups. Another aspect is people funded to do something different. They were just exploring the universe, looking at the expansion rate, not expecting to see a deviation from the standard cosmological model of the time. And so the other trick is accidental discovery of something when you got funding for something else, but that is in the same topical area. I think, accidental discovery in a different topical area combined with the having multiple independent confirmations from competing groups of something new. These are some of the, I'm not saying it's an exhaustive list, but off the top of my head, to answer your question, those are 2 of the main things I thought of. But we should be clear, a lot of things once considered fringe are like, everybody knows now, meteors, germs that can cause disease, continental drift, the speed of light being a constant, and relativity in general. Like, these things used to be, or atoms for that matter, these things used to be considered nonsense, right? You would be laughed at by not just by the public, but by scientists and philosophers, natural philosophers. They'd say you're a crackpot because you believe in atoms, these little things you can't see, or germs. But to be clear, also, that doesn't mean every crazy idea is always correct. There's plenty of crazy ideas that have been disproven, horoscopes, astrology. There was something called N-rays at one point that was complete nonsense. X-rays turned out to be correct, but there were these other things. So not every crazy idea turns out to be correct. However, I worry that right now science has gone in the over conservative, over skeptical direction to the point that new ideas are stifled. We don't want to run back the other direction either, because you don't want every single nonsensical, disproven thing to suddenly be back on the table. But I think that right now we are very far in our world. We're very far from a healthy center or healthy medium. We're sort of towards the dogmatic end right now in science, where we're not interested in new ideas at this moment within academia, especially.
So one of the things I've been thinking about with regard to this is that as an idea goes from being fringe to being like broadly adopted as a theoretical framework, that can help position it for the funding which we need for verification. So I'm thinking about something like the Higgs boson. Again, I'm a layperson, but I would imagine that started out kind of as an abstract concept, and then it gained enough credence within the scientific community, like long before it was demonstrated to be a real phenomenon. There was a big collective understanding that this was a reasonable thing to look for. And so I'm wondering, do you want to jump in?
Yes. So your example illustrates both of the points I said earlier, and illustrates a third, actually, that didn't happen for dark energy, but is more typical. So the Higgs boson is a great example because, number one, you had multiple independent people. In fact, there were individuals who were really angry they didn't share in the Nobel Prize, because actually, to the best of my knowledge, it was at least 3 or 4 people who thought of the idea at nearly the same time. So again, like my earlier example, you have to have independent, smart people come up with the same idea. In this case, not an experimental discovery, but a theoretical prediction. Okay. Then principle number 2, these were people who were already working in the broad area of theoretical physics or theoretical mathematics of symmetries that could be applied to the problem. So again, accidental discovery is not quite the right word, but these are basically, again, these are people who are already paid to, in some cases, in a sense, they're already working in that general area. So basically what makes UFOs worse, in a sense, or different, it's another entire area of study. And that is much worse. That's much harder to create or to manifest compared to just like a new particle in an already well-established field called particle physics, or in the case of dark energy, a new phenomenon in a well-established field of cosmology. That's a easier sell. It's easier for tough cells in that situation. And there's another factor in the case of the Higgs boson, is it was decades. It was decades of theory papers about it before we could build an experiment large enough, expensive enough, large enough to find it. And so you also had time. And so we've had lots of time when it comes to UFOs, UAP, but it's been riddled with stigma and taboo. So the time, you think, time is on our side. Why hasn't it been normalized? The discussion has been normalized yet because it's been decades. But yeah, most of these decades have been spent on ridiculing people interested in the topic. So we've not had a sufficient amount of time of sort of like a post-ridicule era that has not really happened. We've seen the beginnings of that, I think, but I think the stigma is still alive and well. So we don't have time on our side. We do have multiple groups, but like I said, too many. I think we've gone too far in the direction of too many independent scientific teams doing UAP studies, which, to be honest, that is a better problem to have than none.
Yeah.
Just to be clear, I'm saying, there's too many damn UFO organizations, but I would rather have too many than zero, which was the case for decades and decades, especially after, Blue Book and the Condon report sort of like killed UFOs, and the National Academy of Science says nothing to see here, folks, move along. Yeah. And so I think I would rather have like UAPx and Galileo Project and SCU and the Tedesco brothers, everybody doing their own thing. I would rather have that than zero groups, just to be clear.
So it sounds like what you feel is that we're entering this new age, and the way to move the ball is to get some scrappy teams together to get some data that can give us an argument for bigger research projects, more funding, and ultimately more discovery. And you think that might unfold on the process of decades. Does that sound right?
Exactly. The patience is really important, because even if we suddenly got funding tomorrow, I got funding, or Kevin and Galileo Project got more to keep going because they have, so patience is so. I don't know if you're familiar with John Oliver or the HBO show, This Week Tonight, but he had an episode about UFOs, and he concluded it in a great way. He said that the study should proceed slowly, and most importantly, he said boringly. And so I think it's really important that people are patient, because look, if we've waited 70, 80 years, patience is important. So even if you gave me $1 million right now to pay my salary and get equipment and get students, I'm not going to present you some smoking gun evidence in a week of, the aliens waving from the windows of the mothership. It's not that. It's still, patience is still required, even if we got funding immediately. And it's because in order to get scientifically robust evidence, it takes a while. So it's like with my earlier example, why people get, they lose patience with the FDA or CDC or something. The thing is, but science has to proceed slowly, because it takes time to collect enough evidence and control data and things like that. And if UFOs are tied to some kind of intelligence greater than humans, then wow, that's an even harder problem, right? Because then it's like the ants in your garden trying to study human beings, right? Or rats in the maze. So that makes it even harder. So I think that patience will be necessary, even if we get funding and start publishing studies. The first things we're going to publish are more like null results. We didn't find anything, or we found something ambiguous, like what happened with UAPx. And our first attempt, you're not going to go out there for a week and get lucky and get the smoking gun evidence. That's very, very unlikely to happen. And so what we need now is I think we need to enter an era of reduced stigma, hopefully, where people can get funding to do this. And ideally, right now, we kind of start increasing the amount of collaboration, because right now it's sort of like the Wild West. It reminds me of when when the dark matter field first started, a mainstream field. It's completely not fringed. Well, depending who you talk to, I know Avi Loeb is not a fan of dark matter, but like it's not. It's a well-established mainstream field within physics. Okay. I also know some chemists who would disagree and be like, "Oh, dark matter, that's crap." But it is considered a mainstream field by most. So, and you can get funding for it, like I have. But when the dark matter field first started, there were like 50 groups because everybody wanted to win that Nobel Prize. And then slowly the number of groups collapsed. Part of that was lack of funding. There was still some funding, but not enough to give everybody money. And so there was a natural selection, sort of Darwinian process, or you could say Game of Thrones or Hunger Games type process of people like killing each other off, like career-wise, not literally, of course, and slowly a collapsing process. And I think that the UAP field will go through that. If it becomes a mainstream scientific effort, it's going to collapse to 2 or 3 different competing but well-funded groups that have a respect for each other and have a respectful competition and some collaboration. I think that's the ideal end goal of the next few years and decades, is to have several well-funded groups that can all collect the evidence with slightly different sensors, different brands of cameras, and other instruments, just to get different data, complementary data that can work together, that can be combined in harmony as they publish their own papers.
And it sounds like you think this data is going to be the best argument for more research.
Absolutely.
Does that sound right?
You need physical evidence. You need more than just, photographs. You need videos. You need more than just videos. You need videos from different angles. You need different kinds of sensors. Like I mentioned, radiation and things like that. You need different wavelengths for the optical ones, like infrared, ultraviolet, things like that. You need to get physical evidence that is so undeniable that you can't resort to, it was a bird, a plane, it's AI, trickery, things like that. So the way to do that is you get multiple angles of camera video, and you get different types of sensors that are not cameras, a greater diversity of sensors like Galileo Project, like UAPx did. You need a diversity of sensors like the Tedesco brothers are doing. This is the right approach, is don't put all your eggs in one basket. Don't make an array of 50 cameras, okay? That could be one, if you have the money for that, that could be one aspect. But you don't want to put all your eggs in one basket, like a camera or a particular type of camera, a particular wavelength of light to look at with that camera. You want to try to diversify your sensor suite.
And it sounded like from reading your paper with your preliminary findings that this is one of your big takeaways from your first expedition. Would you like to talk about that a little bit? Congratulations, by the way, on conducting an expedition.
Thank you. But yeah, it was not easy. And we're lucky that we got some publishable stuff. We're very lucky. We got some cool stuff we could write up into a very long paper. So yeah, our preprint came out. I'm the first author on it, but it's a team effort. To be clear, I have to acknowledge all the co-authors on there. We have among the scientific co-authors, we have my colleagues Kevin and Cecilia I mentioned a lot earlier. We have Ben Kugelski, he's an engineer. We've got, and it was a team effort. We have all of the team members, Gary Vries, Jeremy McGowan. We had the Island team, Dave Altman, Michael Hall, Dave Mason, and his FLIR cameras. So many people. This was an enormous collaborative effort. We didn't find any definitive smoking gun. Here's a UFO, and here are what UFOs are. Here's an explanation for them. They're spacecraft, they're this or that. We don't have that, but we did establish what types of things work and doesn't work. And one of the big lessons learned was that having a dozen cameras that are all the same, even if they're all pointed at slightly different angles, that's not as valuable as having a diversity of sensors. And also the problem becomes is when you have that much data, and you've got data of so many terabytes of data, you need human beings and you need human eyes to look at them. And so then again, the other lesson learned was you need to have manpower. It is not sufficient to have equipment or money for equipment. You need to have manpower person power to get people to help analyze the data, and that is crucial. And so there are still mountains of data we didn't analyze because we couldn't get off the ground. We tried to get a citizen science project going. We were using AI and machine learning. We couldn't finish. We still to this day have infrared video hours and hours and hours from that week. We could have a giant UFO in one of them. We wouldn't know because nobody can help us analyze the data. Part of it is we can't send copies to other people because it's so many terabytes. So it's a practical problem with all the video. We have the hours and hours and hours of video. And so the problem is if we had money, then we could pay students here, sit down and look at this video or at least run the software program on the video, look at what it picks up, check it manually, then afterwards. So we've got mountains of data we still haven't looked at from the first expedition, because just 1 week, that's a lot of data. If you're attempting to run cameras 24/7, which we were attempting, we didn't succeed. So, there's power outages, we have gaps, but we still have hundreds of hours of footage to look through. Nobody's looked through all of it. It's just too hard.
This is kind of a deep cut, nerdy question, but it sounded like there was a trigger issue with because some of this stuff is recording really high quality data. The storage was prohibitive for. Do I have that right? That like some sensors or some cameras, you couldn't just store 100% of what it was taking in. So you only start recording when there's a trigger event for some of these sensors. Is that right?
That's correct. So for the FLIR, from Dave Mason, for the forward-looking infrared, we had that was the attempt was to do 24/7, and that's because the resolution was small enough because it's an infrared camera, so they're not up to the same abilities as visible light cameras, are nowadays. And so these were a lower resolution, so we could store more, and we were running them pretty much constantly. But then there was the UFO-DAP, which was higher resolution. That camera 1280 by 720. I mean, we can do better than that nowadays, right? With 4K and things like that. But the problem is you don't want to do too much better because where are you going to put it, right? Where are you going to store it? So with our UFO-DAP camera system, that was developed by an LA area engineer named Ron Olch, who sells these units where he takes existing things and adds more sensors. Problem is that in our paper we talked about it was triggered. Which saves disk space, and you're not like saving continuous video. But then what happens if the trigger's not properly calibrated is you could be missing interesting events, right? And then or watching them late, right? And on the flip side of that, what ends up happening is you trigger all the time on like a mosquito flying by, and then you have all this garbage video to look through. And so it cuts both ways. You both collect, you simultaneously collect too little and too much, if that makes sense. So because trigger's not properly calibrated. So another great lesson learned from our first expedition, because like most of the people on UAPx, especially scientists, were not field, scientists, not that kind of scientists, not used to deploying stuff in the field.
Sure.
Like when I work on my dark matter experiment underground, that's not the same. That's not like a field deployment, anthropologists and geologists might do things like that.
Yeah, that's another example of a challenge in the UAP studies space is you're bringing tools to a new kind of environment and trying to work there. The follow-up question I had about the triggers was, do you know if there is software that would allow you to do a rolling delete so that you could, if you got a trigger, then look at the 5 minutes before that trigger because the system had like deleted everything 6 minutes plus? Does that kind of software exist, or would that have
to be? Absolutely. There are cameras that have onboard memory that lets you do a rolling buffer. There's FIFO, there's LIFO, first in, first out, last in, first out. There are all kinds of options.
That's cool.
The issue is that we were kind of, with the first expedition, kind of thrown into things. Because remember, we have our day jobs. I look for dark matter with my colleague Cecilia. Kevin, he does quantum foundations, he does exoplanets, he does other things. So we do not have the proper time, because we're not paid to do it, to prepare the proper procedures for calibration, especially calibrating triggers and things like that. So these are all things that are common sense things that we know we should have known, and we do know, but there was just no time. And so we just kind of threw things together when in what you need to have to do, and we say this in the paper, is that it's really important to have calibrations before and after. And you need to and that includes you need to select camera settings. We did not have the optimal settings on things like the UFO system because we didn't understand its software because we just got it like the day before we started the expedition. And so we didn't have time to explore these settings. Like, let's do a pre-trigger of so many images because then we can see it pre-trigger. I mean, it's the kind of stuff we do all the time. When I was a grad student, we do this all the time on the bubble chamber-based dark matter experiment. I set it up where the first image was not the event, but the first image was like 5 frames out of 10 before the start of an event. This is all doable. Cameras nowadays you can get cameras that have onboard RAM, or you can get cameras that are saving temporarily to the hard drive the initial, or even permanently, the initial pre-trigger images. So you can be sure that, because what often happens is when we talk about something appearing on a camera image or any kind of scientific endeavor where you're looking for an event in the most general term. Usually what that means is you're looking at 5% or 10% or 1% of some maximum defined in the software, which means you're chopping off a little bit wherever that event is forming, if it's an image or whatever kind of data. And so by definition, you are often with acquiring data of any kind in science, you need to have like a buffer before like an event is, before your trigger condition. And that goes not just for cameras, like I said, but just, magnetometer, that is another classic tool for UAP studies. You want to have like, look at the data right before your alleged spike to see that it was flat before that spike, you see. So I'm not just talking about camera images. What I'm talking about is very, very general, is you got to have some sort of like pre-trigger buffer. We just didn't have all those settings optimized because we were just like, okay, we're filming in July and we need to go. And like, it was just the day and the time, the month was picked, the week was picked, and there was no time to finalize our understanding of our own equipment. And but that's not going to happen next time. But right now there is no next time unless people give us money. There's no next time. So
let's talk about that next time.
Yeah.
What would you love to target, and how much do you think it would cost for expedition number 2?
So we would love to target another hotspot. Like there could be one local to Albany. There's the Pine Bush area where supposedly they see lights along the Hudson River Valley. But it would be nice to also be able to do another Catalina expedition. But right now, I mean, with the LA wildfires and like the expense of even just like the expense of like lodging in California, that's just like, that should be so expensive. It's practically a non-starter. But it would be nice to do maybe like a local expedition to one of our hotspots that are within driving distance.
Yeah.
And that we could do again for, just few tens of thousands of dollars, haul the equipment we already have. But the most important thing, like I said, is to pay ourselves.
Yeah.
Right. And to pay our travel expenses, things like that. We can start by putting the equipment together we've already bought, we already own, start there and work our way up to bigger grants. Later. But right, we're not talking about millions, we're not talking about billions or trillions like the Defense Department budget, for tiny, tiny amounts of money. And also I need to emphasize it's scalable, because I always got that question, how much money do you need? And it's really, well, how much success do you want from us? So basically it's scalable, right? The more money we get, that just means more time we spend on it, better equipment we can buy, more students we can hire to help us. So it's really scalable. You give us, 10 grand, we can do almost nothing. 20 grand, starting to be able to do some more. 30 grand, now we're talking, we can actually, do a week or two of something. So like the more money you get, so it's scalable. And when I say success, that doesn't mean, find smoking gun evidence. Success is defined by getting good data. And good data doesn't mean, we found something. It could be more null results. My entire dark matter field is based on null results, but something publishable at least. Where, look, we did this expedition for X number of days or weeks and we didn't see anything, but here's all of our wonderful data. Here's all the potential anomalies we caught. And here's how we debunk them, self-debunk them, and explain them, like we did also in the first UAPx paper. So really, there is no one answer to like, well, how much money do you need for another expedition? It depends where we go and for how long. So the more money we get, the more we can achieve. And so it scales with but we're happy to start humble with a tiny amount of grant and just in the tens of thousands, which is tiny compared to, $1 million government grants. It's a drop in the water compared to the Defense Department budget or to Musk's wealth and things like, and people like that.
Sure. Or even the amount of money that we spend researching dark matter or smashing particles together.
Exactly. It's a tiny fraction of my dark matter field. It's a tiny fraction of LHC budget, which, to be clear, it's hard to get that tiny fraction because we can't even get money for mainstream efforts right now are getting scaled back. So a lot of my colleagues, their mainstream efforts are getting cut. And that makes it even harder to try to get money for this controversial, fringe, taboo topic when, the mainstream areas, we're getting squeezed in dark matter right now. I can't afford right now more than 1 or 2 students. That's on a mainstream accepted field. So can you imagine how hard it's going to be? But I think one thing that could make it easier is I think that this topic captures the imagination of the public in a unique way. And so I would imagine that makes it easier. But again, it's a zero-sum game. I would hate for money for UFO study to put one of my friends out of work who works on the LHC, or who works on my dark matter experiment with me, or on a different dark matter experiment, or a different experiment in a different field. The problem right now is it's a zero-sum game. So giving money to X for science means that Y gets less. It's just reality of the federal budget.
To your point about the broad interest here, a couple people who have commented on some videos, like the one with your colleague, Dr. Knuth, actually mentioned the idea of crowdfunding. And I was wondering if that's something that you've looked into. And also just want to flag, if anybody's listening and knows how to make those campaigns work or has experience in online marketing, it sounds like that's the kind of volunteer energy that you could use in your area. I don't know what the biggest crowdfunded award has ever been, but it was probably a sneaker project or something. But I would imagine that you could scrape a few tens of thousands together. I just don't know much about having how to do it, and I was wondering if it's an avenue you've explored.
We've thought about it. It's definitely on the table, but the thing is these kinds of initiatives don't really produce in general anywhere near the amount that we need, even for the lowest numbers I was giving you. We could scrape together a few thousand, and we have a few thousand in the coffer that keeps the lights on and keeps the UAPx website running, even though we haven't updated it in years. And we get angry emails from people who are like, we don't have a webmaster, okay? They're like, your webmaster needs to fix this and that. I'm like, there is no webmaster. There's just us. There's the scientists and Gary, who's in charge, Gary Voorhees. So there's no webmaster. We have no money to pay a webmaster. The thing is we've thought about that, but there's definitely, I think in general, those types of initiatives don't quite raise what we would. It wouldn't get enough money to a critical threshold where we could do anything interesting. We do accept, it's on the UAPx website. We accept donations of any size. We really, I know Gary really appreciates them, any size, $1 even here and there. But the thing is that even if we launch something at a crowdfunding website, we're not going to get to, and also there's a psychological factor that a lot of these crowdfunding efforts, if you look at them, they often, our goal is to get $10,000 and they peter out after $1,300 or something. I mean, there's an initial jump when you advertise and it kind of peters out. And then what do you do if you only raise an X% of what you actually need? Would you give the money back, or you do something half-assed? You know what I mean? It's a tricky situation. So people always ask us, oh, why don't you go on GoFundMe and start a UAPx thing? And there's another reason why, which is then we are further splitting. We already have all these organizations. Like I said earlier, there's so many different organizations. All of them are trying to raise money for UAP studies, and they're all competing with each other.
Yeah.
And so basically people don't know where to put their money. So even if we start something, people will look at that and be like, why should I give money to UAPx? I already gave money to Galileo Project, or I already gave money to SCU or SUOPS. And so there's all these acronyms, right? All these different organizations. So those are kind of the sticking points, but it's definitely on the table, something to do after, for example, our paper, which you said earlier is forthcoming, which it's true, but also not true at the same time. It's complicated. Our first draft before peer review was made public in December of 23. And so that's where, you're able to read it, download it from the web, but it's not officially published through peer review yet, but close. We should be able to get that in a major journal, get that published. And we're thinking that's the moment to then remind people we exist and be like, hey, please give us some money. So we are going to go for a strategic approach. We also are in talks with different organizations. I don't want to give too much detail because nothing is solid yet, but we are trying really, really hard to put our pride aside, to put ego aside, and to go find another organization that will merge with us. And it doesn't even have to be an equal basis. We can be the junior, partner, go with one of the more established groups that existed before UAPx. So we're talking to multiple different organizations right now and saying, look, will somebody please absorb me, and Kevin, and let's look for money together. Let's unite, which would be a first, I think, in UFO studies, because you always have people who are like, screw this. I don't like any of you guys. I'm starting my own group. This happens all the time.
Yeah.
How often do you see the opposite? I think Twitter would break. The internet would break. It would flip out. The UAP Twitter would go ape shit if two organizations were like, we're putting our differences aside and we're merging. People would be like, what? Nobody merges. Nobody buries the hatchet. Everybody starts new fights, right?
Yeah.
It's human nature. And so we're working hard in UAPx to be the first UFO organization ever, to best of my knowledge, I could be wrong, that merges with another currently competing or complementary organization with different or similar mission and scope. And we might be one of the first, or at least one of the first, to actually go and merge with somebody else and pool our resources together. Not just collaborate, not just throw our names on each other's websites, but actually UAPx is actually thinking of closing up shop and merging with another group wholesale.
And meanwhile, you've got the expertise that you've developed a little bit by doing an expedition. You've published on this. Other people can read that and say, oh, okay, I do need duplicate sensors and multiple sites and logged calibration and synchronization of my equipment. Need to know where everything is physically, down to the inch. And I need to know we need to synchronize the time down to the sub-second, you said. I just want to replay the funding tiers as I understand them. One, crowdfunding, the plus is that there's broad interest, but the downside is that it's hard to get enough money from that. Medium range, you've got millionaires and billionaires who are potentially good sources, but there are only a few of them who are interested, and they're hard to pin down, and they're split between multiple groups. And then the biggest and most helpful would be official government organizations, like the kind of foundations that fund big particle research. And the plus there is that they could output way more money, but the downside is it takes time and political energy to get these agencies to set up such programs. And then you also potentially run the risk of political interference by whatever shadowy forces like to quash things like eminent domain clauses in UAP laws. So does that sound a bit right as the playing field of funding to you?
Yeah, well, we've tried private foundations too. That hasn't come up yet, and we don't even get an answer because probably people laugh their butts off, right? Because again, also, it's very rare. As I said earlier, it's almost non-existent. And earlier, I claimed it was totally non-existent. The open-ended, proposal to somebody for a completely new initiative or idea. It does exist, but it's rare. And they're not going to accept. UFOs, we don't even get an answer. I think one time I got an answer, and it was just some vague thing about how this isn't a real field or real topic or something like that, and physics at least. So the private foundations. I mean, we've tried that approach at least on UAPx. I'm sure Galileo and others have, and so the problem is that the stigma still exists, and you have very vocal people out there who are still trying to kill this. You've got Mick West, you've got Stephen Greenstreet, who's much worse, because Mick West I can at least have reasonable conversation with it. So there are people out there who are actively against this, saying nothing to see here, move along. And it's a paradox. And I point out the circularity of this is, why is there nothing to see here? Because you're not allowed to study it. Why are you not allowed to study it? Because there's nothing to
Because
see
there's nothing
there.
to see here.
So
Yeah.
there's circular logic, right?
Right.
And so and I love how none of the debunkers seem to recognize the immense circularity of their logic. What are they so afraid of? If there's nothing to see here, what's wrong with a scientist like me, quote unquote, wasting my time doing something that is fun if there's nothing to see there, which I disagree with, but it's not just that, oh, someone's wasting their money so I can have some fun. I'm training students on skills that are of broad applicability. Teaching students to do camera and video processing, to do, radiation detection. These are things they can take to any of the mainstream fields of science and engineering. So the money is not wasted. Nobody's time is wasted. If not a single UFO is quote unquote real, that still means $0 are wasted and nobody's time is wasted because they're learning valid science and engineering skills. Students learn the scientific method, working on the topic. So basically, I completely push back against the idea that's propagated that it's a waste of time and money. That's it's completely false because it's such an interdisciplinary topic that people can pick up general skills, especially student interns can pick up general skills. And that's been the philosophy I know on Galileo Project. And if we ever get any more students, that'll be our philosophy, at UAlbany and UAPx.
One other funding idea that came up for me there was that, to your point about existing programs, sometimes expanding into fringe science, there's METI, Messaging Extraterrestrial Intelligence, and SETI, Search for Extraterrestrial Intelligence. I know those are both scrambling for $2 anyway, but then there's meteorology, and I was wondering, people mentioned ball lightning and plasmoids, and I was wondering if you thought there might be an avenue in to kind of like take more of a meteorological tack, and then if you find some UAP, expand in that direction, because I've heard you say in other interviews that whatever we find about UAP, it's going to be very interesting. So regardless of whether the extraterrestrial hypothesis or some other interesting idea turns out to be true, there's clearly something interesting going on that we could learn more about.
Exactly. Now, but part of the issue then there is if you take that approach, people are going to say, well, you're a particle physicist. Why are you doing atmospheric science? So people are stovepiped. And so the issue is you can't do something out of your discipline. So we no longer, we pay lip service to interdisciplinary. But if someone attempts to be interdisciplinary, you're told, what the hell are you doing here? You're not a geologist or a meteorologist. Get out of here. Okay. And so you're not going to get funding for those kinds of things. And so I totally agree that there's probably some natural phenomenon aspect here, almost certainly. But if something is atmospheric, a non-atmospheric scientist is not going to give money to study it. So part of the thing is you need to build, part of the solution is you need to build interdisciplinary teams. You can't just have physicists. You need to have chemists, atmospheric scientists, geologists. You need people bringing their different skill sets to the table to study this interdisciplinary topic. Because I'm of the opinion that we're lumping a bunch of things together. And to me, UAP is literally what it means. There's a U. And it's like UFO. The U means unidentified. That doesn't mean it's an alien spaceship. There could be all kinds of other things that we are conflating. I had been asked about, UAP propulsion, and I'm like, so you mean alien craft propulsion? Because UAP. So if I'm a glowing ball of light, what is my propulsion? Or if I'm just a glowing plasma, like it doesn't make it. The question makes no sense, unless we're talking about a metallic craft built by an intelligence. The word propulsion doesn't necessarily make sense. And so basically, I think we mentioned this on page 1 of the UAPx paper. We're conflating probably with our current terminology. UFO and UAP will probably in 100 years realize it's 2 or 5 or 10 or different categories.
Yeah.
And even one of those categories, let's say the extraterrestrial hypothesis is correct. Who says it's one species? You know what I mean? Like, it's still a multifaceted problem. Even if only one hypothesis turns out to be a predominantly correct one, I don't think that's going to be the case. But if it is that one is a predominantly more correct than the others, it's still multifaceted. You still have multiple facets to that hypothesis. So I think we're conflating a lot of things together right now. And that's fine, because that's not a negative thing, because that's how science has to start. If I didn't know anything about flying creatures, I would call birds and bats the same thing, right? This is what Kevin Knuth always says, is if we didn't know what flying creatures were, we would call birds and bats and insects that fly, we would just throw them all together.
Yeah.
And be like, these are flying animals.
Right.
And so I think the same thing's happening with UFOs or UAP is there's probably completely unrelated phenomena that are not part of our current lexicon of nature, and we're kind of throwing them all together. But what we need to be cautious of because of this, you cannot explain one unknown with another. So I love it when a debunker will say, oh, that's not an alien spaceship, that's ball lightning. And it's like, but most scientists still don't even believe ball lightning is real. So you're going to take one unknown and you can explain it with another. That is an intellectual dishonesty if you're doing it, consciously. It's a cop-out. That's a cop-out. I mean, it could be the case that the UFO they're talking about question could be ball lightning, but I think people who will use this approach will do it disingenuously much of the time. I mean, it's totally okay to be like, oh yeah, that UFO could be ball lightning, as long as you then don't turn around hypocritically in the same breath and then ridicule atmospheric scientists who study ball lightning and saying they're crackpots too. Because I'm sorry, you can't have the cake and eat it too. So if that UFO is ball lightning, now you're admitting that atmospheric scientists should get money to study ball lightning and figure out what the hell it is and if it's real.
Yeah, it's just kind of trading one question mark for another, it seems.
Exactly. You're trading, you're just shuffling the deck. You're just doing a switcheroo of circular logic again, as of one unknown with another.
You mentioned propulsion earlier. Did you teach a course on interstellar propulsion for SUAPs, the Society for UAP Studies?
I did. I most certainly did. And it was really successful. I had one of the largest courses ever. I think I ended up with like 45 or 50 students in the end. Nice. I hope to do it again. I really, really want people to take it. It does cost money. I have to be honest and open, but that money goes to, I'm a professor who doesn't make a lot of money. So that money makes sure, I can pay the mortgage, and keeps me out of the poorhouse.
Yeah,
so
I think it's great.
My income as a professor is not enough. And so I do make some money off of it. I'm being completely honest and open. It's because I had complaints being like, oh, information should be free. Yes, I agree. But then I should be paid a living wage, by my university. So yeah, but so you do have to pay for it. But if you talk to my former students, I'm sure they'll tell you that it was worth every penny. And it doesn't all go to me. It's also split with Society for UAP Studies, which just like UAPx and SCU is a non-profit organization. So no one's pockets are being lined. Like I said, I'm getting some of it, but no one at SUAPs is making any money off of it. It's going into their budget for being able to pay for research and conferences on the topic of UAP and things like that. Nobody's getting rich off of my online class or any of the other SUAPs classes. Because I'm not the only class. So many classes are offered by a Society for UAP Studies offers a lot of different online classes.
I think that's a great idea. I love the commercial academic idea in general. I think more people should engage with it kind of like recreationally or because they're really interested. And it's a great avenue for people who have built a career where they know a lot like you to share and make some money, support your family while teaching people interesting stuff. I would love to just ask you a couple of questions about this because I'm curious. I'm wondering about your intuitions as somebody who's pretty deep in this field now about the possibilities of faster than light travel. I heard you mention elsewhere in a couple places that at relativistic speeds, it's possible that starlight can become fatal. And I would love to hear you explain that a little bit because I've never heard that before.
Sure. And it's just not your fault because it's the science education system in the country. So it's not your fault, but I'm always sad when I hear these things that basic physics that's been understood since 1905 has not been taught in middle school, has not been taught in high school. No, it's not your fault. It's not your fault. It's the fault of the science education system, in this country. But basically, I see this again and again. I was just listening to a podcast the other day, and I thought I'd have a brain aneurysm. Because I heard a smart person say, oh, it's impossible to cover interstellar distances because you can't travel faster than light. Mm-hmm. And I wanted to reach through my phone and throttle, this speaker. It's this is so false. You don't require faster than light travel because of time dilation. So time slows down. So, I cover this in my propulsion class, for example. Everyone always repeats this nonsense, this myth. It's that, for example, the Andromeda Galaxy, 2 million light years away, that means it would take 2 million years to get there, right? False. You can do it in 50 years. If you travel, you don't have to travel faster than light. You travel slower than light, but time slows down for you. And so the fact that time dilation, something that has been understood for 120 years this year, I'm talking about the anniversary of the publication of Einstein's theory of special relativity. So for over a century, so this is not new physics. This is not new science. This is not fringe science. We use relativistic time dilation every day. For example, we correct, our GPS satellites for time dilation. Because they're going, 17,000 miles an hour or whatever. They go not close to the speed of light, but still enough to have a very, very small impact. So it's not just a theory that we can ignore. Time dilation is real. You probably heard of the twin paradox and things like that. It's not a paradox. It's only a paradox if you don't understand the theory of relativity, special and general. So the thing is that faster than light travel, while nice, is 100% not necessary. This is one of those straw man arguments that is put up in order to debunk the extraterrestrial hypothesis, but it's a straw man argument. The argument goes as follows. The interstellar distances are too great, and you can't travel faster than light. Therefore, you can't cross them, and aliens can't visit. This is a straw man argument because the distances contract and time slows down. And so there's plenty of time to cross the distances, which are not that vast, when you travel near the speed of light. So if you're traveling only 0.1, I think it's 0.06 meters per second slower than the speed of light, and you try to go the Andromeda Galaxy 2 million light years away from your reference frame, it's actually only 50 light years away. That's an enormous contraction of distance. So there's Lorentz length contraction, there's Lorentz time dilation. So all of these factors, they're not the same as space-time warping, warp drive, fast light travel, any of those things. Those things are nice. And I'd like them to exist, but they might be impossible. And that's okay. Fast light travel might be impossible, and I don't care. And neither should people who think that the extraterrestrial hypothesis is valid, because it's irrelevant. Because you can just travel really, really, really fast, slower than the speed of light, and allow time dilation and length contraction do the hard work for you. Now, does that mean it's a walk in the park? Of course not. Because you mentioned, so starlight will be Doppler blue shifted up to fatal energies, like to gamma rays. So basically the way the Doppler shift works is that when you travel relativistically, light behaves like sound. So you probably heard the Doppler shift of sound, a police car going by an ambulance. If you're traveling near the speed of light, so light will shift color. And that includes to invisible colors above violet. So you go red, orange, yellow, green, blue, indigo, violet. And then beyond that is ultraviolet, X-ray, gamma ray. And so what happens is that, let's say I have, yellow light, or blue or something from a star, okay? As I'm moving near the speed of light, that starlight as it is coming at me, it's shifted, its wavelength is compressed, and its energy is increased in my frame of reference so that it can become, things that are now dangerous to me. Gamma rays, X-rays, things like that. So that's the basic idea. And it's not just starlight. It's also other natural phenomena in the universe, like the cosmic microwave background radiation will get Doppler blue shifted up from microwaves up to fatal types of things like gamma rays and X-rays. So some of my critics have said I claim interstellar travel would be easy. Not saying it would be easy because of relativity. I'm just saying that I disagree with people who claim it's impossible, because you can't travel faster than light. So they use that straw man argument, they say it's impossible. I'm not claiming it would be easy, because we as humans have not solved the problem. We don't know how to shield against radiation, because again, when I say radiation, we're talking about things like starlight that are normally like not fatal, to humans. But these are the radiation you experience traveling near the speed of light would kill you with current human technology. But then that's used by skeptics to say, that means it'll always be impossible. We used to say the same thing about airplanes. The New York Times wrote an editorial literally 2 weeks before Wilbur and Orville's flight. I covered this in my class. And they said airplanes won't be built for another few million years. Like, they wrote this. The fucking New York Times wrote this. You know,
my
they
God.
should be ashamed of themselves, the stupidity that they put. It's not a unique example.
No.
They also published editorials and op-eds about how space travel was impossible. We will never have space travel. We'll never go to the moon. We will never, because it's impossible. And I think it's ridiculous for someone to claim that just because humans haven't solved the radiation shielding problem, that a civilization that could potentially be thousands, millions, or even billions with a B years older than humans, you're telling me that a several billion-year-old civilization will have never solved interstellar travel? Really? Like, that to me is an extraordinary claim without any extraordinary evidence. In fact, all of the evidence from, if I take examples from human history, the only examples I can take, all the evidence is against the naysayers. Nuclear weapons, turns out they work. Nuclear power, turns out it works. Airplanes, turns out they fly. And so, you know, it turns out that a lot of the anti-technology naysayers, a lot of them have been proven wrong. History is not on the side of naysayers. And instead, they end up getting quoted for years and decades so that people can point their finger and laugh. And so I think that that interstellar travel is hard, very, very, very hard, but it's not impossible. And so I'm open to the possibility that some tiny subset or some tiny fraction of unexplained UFOs, UAPs could constitute some sort of alien craft from beyond the Earth and beyond our solar system even. I think that that is not dumb. I don't think it's funny. And I think it's not to be ridiculed. I think it's a very serious hypothesis, along with the other so-called crazy ones, interdimensional, whatever you want to call it. I think these are reasonable ideas, and I think they need to be taken seriously, and they need to be explored as potential explanations. Now, am I sold it's all aliens? No, absolutely not. I'm not sold it's 100% all aliens, because we don't have the physical evidence. We have testimony. We've got David Grush talking about crash retrieval programs, but unfortunately, he can't produce for me an alien body, you know, a piece of a ship, because that's classified, obviously. I'm not blaming him, but currently we are at the level of trust me, bro, you know, with witnesses, where I do want to believe, like you said earlier, I want to believe, like Fox Mulder's poster, but there's no physical evidence from any of the whistleblower claims yet. I hope that turns around, and I hope we start getting some physical pieces. I want to see a dead alien body dragged in front of Congress. The Onion had an article about it, but I wanted to see it. I want to see it really happen. Because if these things are real, and I'm entertaining the small chance that they are, a non-zero chance that they are, I'm ready to see that evidence. Let's see it. Let's get it out there.
I strongly agree, and I've been building some kind of framework around just the logic of this. I would love for the simple deduction process of exploring the last 80 years of data to help people get to a place of feeling that this is intuitive. I think where everybody is the universe is so big, there's probably life somewhere. And I would love for us to get to a collective place of, oh yeah, the universe is so big and so many civilizations are likely ahead of us that life is probably here and has been checking us out because they figured out how to get here. They probably move around more easily than we expect. And I think the one other assumption that people are missing is that they would be cautious, which I think you can kind of get to if you imagine how we would behave if we went to another populated planet and ask just like, how would humanity interact with that? I think we'd be very careful. I don't think we would land on the Purple House lawn or whatever they had. And it seems to me like that logic should kind of drive enough interest that there should be more funding and more research. And I'm surprised and sort of disappointed that it hasn't after 80 years of sightings and, 100,000 plus documented cases. So I thought I'd ask you if you have any further takes on that, just about the project of making this intuitive for people, just from a logical perspective.
I think, the number one issue is getting people to understand that the speed of light and the great distances, ramming that through people's heads, that is not the barrier that has been claimed over and over again by both scientists and non-scientists. Like I said, I just heard it the other day again on a podcast where I'm like, you have no idea what you're talking about. So I want to stop talking about faster than light travel and say instead that faster than light is optional. It's icing on the cake. I mean, the problem with that is it's too nuanced and people don't get it. And so I almost want to ban discussion of faster than light travel warp drive and be like, just forget that shit and remember time dilation, time dilation, time dilation. Like pupil dilation is the same word as, when they dilate your the pupils of the eye doctor. If I could, Stephen Hawking was asked this question, by the way, before he died, about what's the one thing he wants people to understand from his work. This is not my work. It's Albert Einstein's, and it's ancient. Well, not ancient. It's 120 years old. The one thing, if I could get just one thing for people to understand, skeptics and pro-UAP or whatever you want to call them, I just want get one thing to be understood by everybody. Skeptics, debunkers, true believers, whatever. I just want everyone to understand time dilation. And Kevin Knuth, he's the one who's convinced me of the importance of he's the one who started ramming this before I did, ramming this into everyone's heads. But now I'm following Kevin's lead and saying, can we forget the warp drive shit? Okay. Can we please put that aside and focus instead on the fact that faster than light travel being impossible, if it is, bears no relevance on the question of whether aliens could make it all the way here and visit Earth. It is of no relevance. So I'd love to stop propagating the myth that the distances are too vast and the times are too long for either human interstellar travel or alien interstellar travel coming to us. I want to once and for all put that on the shelf of incorrect human ideas. And every time I put it back on the shelf, someone takes it back off the shelf, because every time I put it, I go, and because there's 8 billion people on Earth, is I go find some YouTube video where someone speaks this nonsense yet again. And sometimes very smart people will say it. Neil deGrasse Tyson will say this over and over again. He's a physicist. He's a smart person. He should know better than this. And so he keeps trotting out the straw man argument. Oh, the distances are so vast. And I'm like, did you ever teach special relativity? You had to. You had to teach it. You had to learn it for your physics degrees. Did you forget it? Did you get knocked upside the head and forget basic physics today? But then if I would say that to him, he'd get mad and be like, oh, but it's impossible to engineer. And I'll go, oh, you mean like airplanes and like Sputnik and all these other things that used to be impossible to engineer, even though they weren't against the laws of physics. So I think interstellar travel is incredibly hard. It would be harder than air travel, harder than any technology humans have ever developed. But hard and impossible, there's an infinity of difference between those two words. I can make something extremely hard. Oh, it's going to take us millions of years. That's still infinitely different than claiming something is 100% possible, right? There is a huge gap between saying something is very hard and saying something is impossible. So I just want to ram home to people that not only is the universe vast, those vast distances are not impossible to cross. Not if a civilization has been around for thousands, millions, or billions of years longer than we have. That's the most important takeaway from me.
Thank you for that highlight. I will remember that and push time dilation in every conversation going forward. Because you mentioned him, it occurred to me that some of these science communicators who were very popular and maybe kind of not read in on the UAP subject, like Tyson, and I think maybe Brian Greene too falls in this category, seem like potential problems now, but they could also be really powerful allies if we can kind of turn them to our cause. And I think we kind of have Miki Okaku, which is great. So that he's a voice out there that people trust.
Well, sort of, but then now he's been labeled as a crackpot. And so the problem is if you don't reach critical mass, the one or two science communicators who are like, hey, UFOs might be aliens, they'll just be swept aside. So the problem is it's like the Cassandra effect of, one person could be right and screaming at the top of their lungs. It doesn't matter. You need to reach critical mass of multiple people all agreeing on the same thing. Next to you wrote there, what must we believe? And I really like that, because here's the thing. I am not entitled to force my opinion on you. but I am entitled to force facts on you. I'm sorry, if there's a fact and it's part of reality, I don't give a damn what your opinion is if it disagrees with the facts, okay? And so then we get into gray areas and people argue about what is a fact, but if something is objectively real, I have every right to force a belief in that in you because it's freaking real, okay? It is reality, it is a fact. If aliens exist and you disagree, that is not opinion. If it's a fact, I'm going to force that fact on you. It's not a fact yet, okay? We don't have definitive evidence. We've got stories of abductions and beings, but we don't have physical evidence that's been verified by independent teams, published. But again, part of that is circularity. We probably have that evidence, but it's probably blocked because people don't allow publication of evidence because of the stigma, because of the taboo. And so we might already have evidence of what UFOs are and have solved some mysteries, but we're not allowed to come forth in a manner that would convince people like Neil deGrasse Tyson, science communicators, as well as the scientific community at large.
That's frustrating. And it feels a little weird too. I grew up thinking we lived in a world where the most advanced truths were publicly available. And it's strange to think that there might be some knowledge about the nature of reality that's walled off behind a military cordon. And I don't like that feeling. Do you?
Yeah, no, I don't. I hate it. It's entirely possible. But what really bugs me is humanity is so bad at cooperating. We have all these wars. We have wars all the time. How is it that we've managed to get all the governments to cooperate, to hide whatever, if there is a non-human intelligence involved here, why doesn't a flying saucer crash in a country that doesn't have a central federal government that's able to seize it and suddenly it's in the public domain? Why doesn't that happen? I think it's inevitable. That's the second paper I wrote is one on catastrophic disclosure, because I think it's inevitable, especially as cell phones propagate, including to developing nations. I think it's inevitable that if there's something to this in terms of an intelligence, non-human intelligence perspective, if that's the correct explanation or correct partial explanation, you're going to have a catastrophic disclosure at some point. So you can't get government. Some countries don't even have a government. They're like in permanent civil war. How are you going to, you're going to have a crash in some country that doesn't have a central government or has a government that hasn't signed some secret deal with the US, like in the X-Files, that isn't one of the Majestic 12 or whatever with the smoking man, and his people. And I think that's inevitable. And if I was the government and if I was one of the holders of the secrets, I'd be really scared right now. That would keep me up at night. And I would decide, it's better to just disclose what I know now and control the narrative rather than waiting and letting shit hit the fan later. Again, this is all assuming there's something there. I'm open to the possibility there is something there. It's not just all ball lightning and stuff like that. There might be some machines, like actual metallic craft, like the saucer in your picture. I think it's possible. And if it is possible, I'm going to be furious if decades of stigma, or centuries even, maybe worse than decades, have prevented scientists from finding the truth, let alone the general public. I'd be furious about that. Absolutely furious. Because what gives a few human beings the right to keep the truth from scientists, keep the truth from me, to keep the truth from the American people and from the people of the earth everywhere? If there is something out there, non-human and intelligent, we have the right to know. I don't buy the whole society will collapse. Yeah, let it collapse. I don't care. I need to know the truth. So I don't like hypothetical scenarios of societal ills to prevent truth from being spoken. That's dangerous. That is a dangerous road to tread, because who decides which secrets are too dangerous to allow the public to know? Who has that godlike power? Who has the right in a free and democratic society like ours to make that decision for hundreds of millions of Americans and for whatever 7 or 8 billion people, whatever we're up to now on Earth?
So I want to quickly ping for people that they can look up how much time do we have before catastrophic disclosure occurs. This is your paper where you crunch the numbers.
I did.
You found a mean time of maybe like 2040. So not all that much time. Yeah. Fascinating subject to explore, and I'd love to, if you would like to do that. But I would also like to ask you about some of your instincts regarding nuts and bolts, and if you have any. This would be moving into sort of armchair speculation territory, but just as a physicist who understands advanced physics, obviously. I'm curious about what ideas you have in your own private musings about what kind of engineering we might be looking at if some of these objects are technological craft. And side question, sorry to pile them up, but just selfishly, I'm curious about the status of spatial dimension theory. Where I left this off, we were at like M theory, and the last physicist I asked said, I don't know, we're not sure. There might be infinite spatial dimensions. And I thought that sounded like too many, so I stopped paying attention. And I was curious what your read on the contemporary thinking is.
All right, but I need to take your questions one at a time.
Okay.
So I got to back it up to, what was the first question again? Crashes?
I guess first I cited your
catastrophic disclosure
paper.
Yeah. So I need to caution you. So that is an average. So it could happen tomorrow or not for 100 years. So I have graphs of statistical distributions, but I made an estimate based on like cell phone ownership density and things like that, and population growth. And I had to make several assumptions. I said, like, if for example David Grush is speaking the truth, I'm sure he is, as he knows it. But I don't know, who knows if he's been fed disinformation, misinformation. But if we take at face value the claim that non-human intelligence exists, it's fallible and it crashes sometimes. Then I assume a rate. I think my default was something like 10 per century or something, and I take into account the Earth is mostly water. I take into account population density, things like that, and I show that based on the number of cell phones we have in our pockets, is that I estimate that what I call catastrophic disclosure. And to just paint a picture, I don't say this in the paper because it's a formal scientific paper, but just to paint a picture, what I'm imagining is like there's a crash saucer, aliens are like climbing out of it, like half dead, injured from the crash, and you capture that on your phone. That's what I was talking about. There's all kinds of caveats. How many witnesses? How do you know it's not AI trickery? I do my best to cover all those angles in my paper. It's not perfect. I've had so many people complain, oh, you don't account for the fact that people will freeze and they won't grab their phone. I'm like, all it takes is one human being for it to happen to who doesn't freeze, captures it on their phone. It's not fake. It's not AI trickery. Okay. And so, yeah, I can't possibly account for all those variables. But the thing is what a lot of people reading my paper don't understand is you don't need to understand all those variables. It's something called a Fermi problem. I can solve something as a Fermi problem. So a classic example of a Fermi problem. So it has nothing to do with the Fermi paradox. The same Fermi, Enrico Fermi. Like one time in high school, I had to solve this question in physics class and can't look it up. Got to figure it out. How many piano tuners are there in San Francisco? You're probably like, what? What the hell? We did it. We did it in the class, and we all got within less than a power of 10 of the correct answer, just making up assumptions. And that's exactly what I'm trying to do in my catastrophic disclosure paper. It's irrelevant if this number's off by 20% or that one by 30%. I'm just ballparking. And based on my ballparking, I show that, catastrophic disclosure might not be far away. Again, with the assumption that we've got aliens, they're fallible, they can crash. Those assumptions are baked in. And so debunker will say, oh, I wasted my time with this paper because those assumptions are wrong. And I'm like, okay, string theory could also be wrong, right? We might have bajillion of these ridiculous dimensions and all that. And so like, just because something's wrong doesn't mean I'm not allowed to spend 5 pages speculating on it. No one's putting a gun to your head making you read my paper. If you think it's a waste of time because you don't think NHI or ET exists, then don't read it, and then just get mad. But then, sorry, what was your second question? So your third was dimensions. What was your second one?
Wait, actually, I just want to dial in a little bit to your paper, because one really cool idea that you came up with was you crunched a number for how many of these things might be on the bottom of the ocean. Dr. Knuth's number about a million years on average they might have arrived here.
Yep.
Estimating some things about interstellar travel, and then you crunch the number of, and I think you got to like 200,000. It implies that there might be 200,000 defunct extraterrestrial vessels sitting on the bottom of the ocean. And that's some evidence that might suggest that Avi Loeb's spherual project is, justified, for example.
Exactly. And I reached out to Avi, but again, it's so hard when you have different competing groups. I don't know if he read the paper, spent time on it. Months after it came out, I asked him on Galileo Project, oh, so this was shared and discussed on Galileo Project. They're like, what? No, it wasn't. I'm like, really? And so this is so unfair. I read your papers by your team members. Like, what the hell?
Oh,
and
man.
so like, nobody's sharing, nobody's reading. And I emailed Avi. I'm like, look, hey, you should read this paragraph because look, you could see, like, you could cite this for justification. He doesn't want to cite my work. I'm a no-name professor at a no-name university, compared to Harvard. And it's really sad. It makes me really sad. But like, I thought like that paragraph really justifies Galileo Project's, scraping of the ocean, because I think that if the crash rate claimed by Grush is true, and Kevin's estimate of when Earth was first found, again, just an estimate, just an average, yeah, there could be hundreds of thousands of ships on the ocean. Sounds like a huge number. Remember, the ocean's big. So somebody might fire back, oh, we would have found them already. Oh, no. Bullshit. The ocean's a huge place. And like the Pacific by itself is huge.
It's like half the planet.
Exactly. So yeah. So and if you count all the oceans, like 2/3 of the surface area,
right,
is not by volume. People make that mistake. The Earth is mostly water. Actually, it's like 5% or something. It's only by surface area, not by volume. It's not like the water goes very deep into the Earth. So basically, it's entirely possible that if ships are like small, like classic flying saucer size, yeah, hundreds of thousands of ships could easily be on the bottom of the ocean, and we'd be struggling, and we wouldn't have found them yet just by accident. That's just math. It's very, very simple because it's just surface area.
That's also a cool example of how this speculative work can build on multiple
exactly projects. There are connections. Yeah. I wrote that paragraph by accident. I realized while concluding the paper, I'm like, oh, wait a second. I just remembered Kevin's paper about, like, he estimated when Earth was first discovered, if there are other races out there or species in the galaxy. And I said I could put that together with the crash rate. And again, the criticism was like, wait, the crash rate has changed over time. And I'm like, maybe it has. How the hell am I supposed to know that? Like, the best assumption I can make is have a flat number. Once I start changing that, it's like, oh, well, why did I choose this slope instead of that slope? And so I've told people who criticize the paper who are pro UAP, I'm like, write your own damn paper. Write your paper and say how I'm an idiot and I got it all wrong. I want people to do that rather than just like in a vacuum or just on email say I'm wrong. Go cite my paper and write your own paper. That's how science works. Science doesn't work via social media or email, or YouTube. That is not science. Science is you write papers and you publish them in journals. You don't like my result, you don't like my conclusions, write your own damn paper and say, I disagree with Szydagis' conclusions. That's how science works. It is not conducted via email or social media.
So parts 2 and 3, I was interested in, do you have instincts about some of the potential craft in like incidents like the Nimitz that Dr. Gnuth explored in one of his papers, estimating the flight characteristics of anomalous aerial vehicles. Another question I have is, what is your take on physical dimension theory or temporal dimension? Like, where are we on that? Do you think there are 13 or 11, or do you have an instinct about how many dimensions? And I guess I'll layer one more on top. If you'd like to fold it in, you can, which is, if we do find out that some UAP are non-human intelligent technology, what kind of science would you want to do knowing that information?
These are all, excellent questions. So let me take the first one. So I think that if I were an advanced non-human intelligence of some kind, I think that my propulsion or transportation of choice would be some kind of space-time warping. That's not synonymous with faster than light travel, by the way. That's another one of those misconceptions, because if you can bend space-time, that is still the best way to travel, even if you can only do it slower than light. So the good analogy is always like the carpet analogy is a good one. If I want to, why should I cross the carpet if I can bring the if I can roll up the carpet and bring the destination to me. And so I think that space-time warping, which, non-scientists like Lou Elizondo have brought up, I think it's reasonable. I think it's a very reasonable hypothesis for how an advanced technology might operate. But there are also more prosaic explanations like ionization of air, to move out of their way, move air out of the way, for example, to prevent sonic booms. We have this technology. For example, I think Russia has this technology too. You can use this for hypersonic missiles, things like that. So yeah, so I think that there are even prosaic explanations that don't require some of the more exotic physics, which I can say is not that exotic, because general relativity is Einstein's theory of general relativity is about 110, 109 years old this year, something like that. And so again, old ideas, not new physics. New engineering, yes, but not new physics. So I think people jump to conclusions like you need new physics to explain UAP propulsion. No, you don't. You need new engineering. Maybe you need new physics too, but I think most importantly, you need new engineering. And so I think it took us centuries to figure out airplanes. So the analogy I like to give is take an airplane and put it in the year 1700, put it in the sky. People would say, oh my God, it's against the laws of physics. Except it's not. That's why I picked 1700, because we already had Newton's laws of motion, Newton's law of gravity. So we already had the principles we needed to explain airplanes. What took us so long? We knew how, in 1687, I could have built an airplane, right? What took us so long? Because it's not physics, it's engineering. Okay, we knew the physics, but not the engineering. So I think it's the same thing with things like Einstein's theory of general relativity. Is like we understand the physics for over a century. We don't know how to engineer it, and so I think there's unknown engineering going on. And so I think we don't know. We know how to take Newton's laws and make cars and make rockets. We do not yet know how to take relativity, how to take Einsteinian mechanics, and turn that into something that can be applied to the real world with engineering. A little bit, we've got GPS, we've got things like that, but we don't have like propulsion based on it because it's not been around long enough. Like I said, look how many centuries it took between Newton's laws of motion, and airplanes.
Yeah.
On rockets, that took even longer. Well, rockets into space. There were rockets, for millennia, but I mean like a rocket into space, like go to the moon, go low Earth orbit, then go to the moon. So yeah, my money is on there is some sort of relativistic propulsion. It probably involves space-time warping. We don't understand it. We might speak of it qualitatively, but I don't think we can have a full mathematical grasp right now, because even though we might have the physics theories we don't have the math, we don't have the engineering to capitalize. And I think that's what, in my opinion, what advanced civilization would be doing would be affecting some sort of space-time warping, because then you don't need a propellant. You need a fuel maybe, so but you don't need a propellant then to propel yourself across interstellar space.
Go ahead.
You go ahead.
I was going to ask if that suggested to you any sensor modalities that you would want to bring to bear on this subject. I probably misused modalities.
Oh, yeah.
Any specific kind of things that we would want to look for to rule in or out gravitational, space-time warping, and or also like the ionization of air that you mentioned, or water.
Yeah, I mean, we can look for electromagnetic fields. So there's nothing new that I can say. Basically, yeah, there's gravitational waves, but that's too hard, because that requires a setup that's miles long, like LIGO. So that's a non-starter.
The effects are too subtle, basically, to know.
Yeah, and the problem is that gravity is the weakest force, so you need to go capitalize it for some sort of gravitational. The side effects would be very small to detect with, at least with current human technology. Okay. So there's I know Lou in his book Imminent, and others have talked about looking for bubbles, warp bubbles in images. I'm a little skeptical on that, because a debunker could always say that's just an imaging artifact. It's not some exotic space-time bubble. So it's really hard to look for those kinds of things. I mentioned earlier Doppler shift. That could be a side effect of relativistic propulsion, but again, it's hard to disambiguate that. Ordinary light that's been Doppler shifted versus just production of ionized radiation from the source. So I don't think we have, with our current technology, I'm not sure I can tell you, and with my knowledge at least, like a definite set of signatures, because again, that would be like asking someone in 1700, well, can you tell me what would an airplane look like and how would I detect it? You were not going to have all the answers.
Yeah.
So I think I can speculate. And I think we can do the best we can based on previous cases and testimony of UAP encounters. We can do our best guesses, but I think that it's hard to say, oh, yeah, space-time warping would cause this, and that. There are lots of people who claim that, And I think they're getting overexcited and jumping the gun and going beyond what I think we know or what we can claim right now. I think we're really diving here into the realm of intense speculation.
That's true. And we're bumping up against our time here. So quickly, dimensions and then what you'd like to do if you think NHI are real. Dimensions over under, more than 10 dimensions, fewer than 10, 3 or 4 is about right, or there are millions? What do you think?
That's an excellent question. So few points I need to make very quickly because, I also need to go, talk to my students and stuff. So, okay, I'm going to anger a lot of your viewers now. Okay, there are, macroscopically speaking, there are only 3 dimensions. Okay, period.
Huh. Okay.
End of story. And I will prove it to you. I can't do the mathematical proof, right, obviously, for you without a blackboard and following. But the fact that gravity drops off as 1 over the distance squared, as does the electric force 1 over r squared, that proves there are 3 spatial dimensions. Okay. Ooh. And I'm going to get a lot of like UFO people who don't frankly understand math or physics who are going to argue against that. Okay. There are only 3 macroscopic spatial dimensions. Period. End of story. That is the end of the story, because gravity falls off as 1 over r to the number of spatial dimensions minus 1. This is a fact that is deeper than physics. It's like 2 plus 2 = 4. It's a deep mathematical fact that forces that propagate in all dimensions in all directions, they must drop off as 1 over the distance to the power. It's a very mathematical thing that people listening, if they're not mathematicians or physicists, they won't get it. They won't believe me that this is provable. They won't believe me. That's fine, but because again, they're entitled to their own opinion, but they are not entitled to their own facts. Okay, so now let's get to string theory and let's get to clues of Klein, things like that. Where are these extra dimensions in string theory? String theory may be correct. There may be extra dimensions, but if they exist, they are microscopic. They are subatomic. So when we talk about 10 or 11 spatial dimensions in string theory, I think it's 10 plus 1 for time, okay, because there's still time there. The extra 5 or 6 other spatial dimensions talking about, they have to be curled up in some way. And in a few minutes here, there's no way it would take me an hour to explain what that means. But bottom line, I need to stress to your viewers, because they'll be super confused by what I said a moment ago. I am not claiming extra dimensions don't exist. I'm just saying that if they do, they're subatomic. So then if we're saying aliens are hiding in extra dimensions, really at the subatomic scale, let's reflect on how dumb that is, okay?
They'd have to be really small.
Yeah, exactly. And so basically, I am not claiming, again, I have to emphasize, I'm not claiming extra dimensions don't exist. But they're not the kind from science fiction. Sorry. Okay. And you're not going to have aliens hiding in like alternate pocket dimensions or whatever. That's bullshit. Okay. So you know how many extra dimensions science has found conclusively after years of looking? Grand total of 0. How many parallel universes have we found? Grand total of 0. How many exoplanets have we found? Over 10,000. How many Earth-like exoplanets have we found? At least 10, maybe 30, not more than 0. And so interdimensional, whatever hypothesis you want to call it, has 0 scientific evidence for it. Absolutely none. And in fact, has counter evidence. Meanwhile, the extraterrestrial hypothesis for NHI has mountains and mountains and mountains of evidence, and those mountains get higher every day. Again, I'm not claiming extra dimensions don't exist. I'm not claiming parallel universes don't exist, but I'm just saying that despite decades of trying, we have found no evidence of it. So let's pursue where we have some evidence. And so I think, like I said, in the past, extraterrestrial hypothesis was a straw man argument because people just say, oh, we can't travel interstellar distances. The other thing is that I should tell you, in addition to my little 1 over r squared trick, which has been known for years, my colleague Kevin Knuth has been trying to publish one of his papers. I hope he doesn't mind that I mention it. He also has a mathematical proof that no universe can exist unless it has 1 dimension or 3, and those are the only options, plus time. So again, more evidence against extra dimensions. But by the way, most people who talk about extra dimensions, they're conflating them with parallel universes. Those are 2 completely separate things that have nothing to do with each other. So I think when most people talk about the interdimensional hypothesis for NHI, they don't have a clue what they're talking about, because they're conflating extra dimensions, which I just debunked. There are no extra dimensions. If they exist, they're subatomic. and they're conflating them with parallel universes. So most of the people who are going to get angry with this episode are going to conflate extra dimensions with parallel universes. They're going to think they're the same thing, and they're going to think I said parallel universes don't exist when I did not say that. I think when most people talk about aliens from an alternate dimension, they really mean a parallel universe, and they don't understand their own terminology.
Yeah.
So an extra dimension is simply another direction in which to move. That's it. It's another direction in which to move. That's all it is. And so if we all live in flatland, if we all lived in flatland in a two-dimensional space, we would have no word for up and down. And we would have no concept of up and down because it would be beyond our understanding. And so an extra dimension, scientifically speaking, not bullshit pop culture speaking and UFO community speaking, but scientifically speaking, is another direction in which to move. And I've already told you, we know there isn't such a direction. It was a hot topic in like 1890s, and then again with Klein theory. But we already know that's wrong. There are no extra macroscopic scale spatial dimensions. I mean, there's some loopholes that might still make it work theoretically, but they're small loopholes, okay? But there could also be parallel universes, which are not just another direction in which to move, in which we don't have words for, we can't explain mathematically. There are still some loopholes, because if somebody is really well-read and knows their physics and watches this, they might say, what about the Randall-Sundrum model? What about Lisa Randall's work? So there are some loopholes. You could have large extra dimensions, but a parallel universe is not the same as an extra dimension. It's an entire universe with its own set of dimensions and potentially its own set of laws of physics. And that they may exist, but communication is going to be extra impossible. So if you think interstellar distances are impossible to cross, they're not. Communication between universes, that's like a whole nother level of hard, of probably impossible. And so that's another separate thing. So again, there are probably no extra dimensions the way that the term is used in this community. But I'm not saying they don't exist. It's just, it would be really weird. So are these little teeny tiny aliens that live on subatomic scales and just become big in our world? Like, it's weird. It's another level of weird where I'm like, look, Occam's razor, let's go. If there's NHI, to me, it's probably ET. And I know a lot of people push back on that, but it's really the easiest explanation that fits very neatly into our paradigm. And then somebody might fire back at me, oh, then there's confirmation bias. Oh, because it fits so nicely into our current paradigm, except that I've got counter evidence against other dimensions and universes. What would I do if NHI are real, right? That was your last question.
Yes, and I'd love to pick up this dimension conversation in a sequel someday if we ever get to do that.
I want to talk to them. I want to communicate. Because why study them when we could just cut to the chase? They could help us. They could tell me what dark matter is, so I don't have to keep spending time looking for it. They've already figured all of this out. Now, there is a danger there, obviously, is that if we learn all the answers, then we don't have, as humanity, we don't have to do the hard work of figuring it out for ourselves. So there is a danger there. But my temptation would be, I want to establish communication and have a conversation about science. I also want to talk about religion. Do you believe in a God or gods? What is your religion? What is your theological framework? And that's actually, I have a unique theory why, and I doubt maybe somebody else has come up with this. I don't think anybody else has. But out of everybody you've interviewed and people probably UAP community, I have a unique take on this. I think one of the reasons why, if NHI are real, if we're already talking to them, like have been alleged by whistleblowers like Grush and others, that we or implied, I should say, by pleading the Fifth Amendment, so to speak, if they're already NHI and maybe we've already even communicated potentially, why don't they just lay on the White House lawn and reveal themselves? Because maybe there's a huge danger. Okay, let's say, for the sake of argument, there's an alien species. They've all got they've got religion. They're not all atheists, like a lot of pro-alien but anti, organized religious people say. What if they're aliens? What if they have a religion? What if it's only one for their entire race, unlike what we have? And what if it's similar to exactly one of our religions? and different from all the others. What do you think would happen? All the religions who lose out, there's going to be huge societal upheaval. And so my hypothesis is that if NHI are real, they might be, it's like a prime directive type thing, like with Star Trek. They might, poke in, play hide and seek, and you see a UFO or whatever, but they don't want to make it official, because if they make it official, there might be something about them that they know would cause a giant problem. Because they might my example is, they might have a religion, and that religion might look almost identical to one human religion and look very different from the others. Can you imagine what would happen to all the people who don't belong to the religion that's the most similar to the alien one? Yeah, it gets pretty ugly, right? It's going to get pretty nasty. And so with murder and terrorism, like on the rise from it would be bad. It would be really bad. And so that's why I think it's part of the reason why. And also, again, advanced technology, if we're not morally evolved yet, an advanced race would not want us to know about their advanced technology, because they know we would just turn everything into a weapon to try to Russia and US will try to one up each other, and China, stuff like, we'll just turn anything into a weapon, even something with the most peaceful purpose, like a freaking alien pair of scissors, but it's better than our scissors and it could slice through metal. You know what I mean? Like the thing that a race uses for some harmless thing, we would find a way to weaponize it, right? We definitely would find a way. And but I would still, as a scientist, my big thing is, let's stop playing hide and seek. I want to have a beer with a gray alien, if that's a thing, right? I'm not 100% convinced, because I've not seen any physical evidence. Show me a gray alien body. Does it have DNA? Is something else? But if aliens exist, my thing is, I want to have beer with an alien, and I want to communicate. I don't care if it's telepathy or whatever experiences say. I want to communicate. I want to have a meeting of the minds, and I want to know what is dark matter. I want to know what is dark energy, and so I want to get some. And if they're not allowed to tell me, because humanity is supposed to figure it out on its own, how about just a hint? Can we compromise? You just give me a helpful hint and point me in the right direction, so that I can, pursue some of these scientific endeavors more efficiently, let's say. So that's what I would want to do. And I think that maybe that's not the answer you're looking for, because you're thinking in terms of scientific evidence of it. But if it's actually NHI, I don't need to study it and find the evidence. It's an intelligent being. Let me talk to it. I don't need to study it anymore if it's willing to talk to me, because why should I try to study it secretly from far away, where it's trying to get it to, if it's intelligent, let me just have a conversation. Let's just cut to the chase. Let's just talk to it.
Thank you.
Yeah, he, she, them, whatever the correct pronoun is for the different species. I don't know what their pronouns are, but whatever the pronouns are that they want, I will respect that. I will use their pronouns. Just tell me what they are. I just want to have a conversation.
And ideally a beer if they drink.
Exactly. If they drink whatever crazy alien liquid they drink, if it's not fatal to me.
Blue milk.
Blue milk.
Or Earl Grey hot, I guess. Thank you so much for spending time. I would love to pepper you with more questions, but I want to respect your time. I know you have prep to do before your semester starts, so I hope we can have a sequel someday as the information around this fascinating topic continues to unfold. I want to applaud you from the bleachers for the great work you're doing, and just thank you as an interested member of the community for your leadership. And I wish you the absolute best this year. Healthy, happy, productive work and life and fun. So thank you so much, Matthew. It's been great to meet you.
Thank you, Caleb. All right. Take care.
And that's the show. Thank you for watching or listening. Please support us on patreon.com/WTUFO, patreon.com/WTUFO. That will increase the odds that the show continues to exist. If you're listening in a podcast format, you can also rate and review us on your podcast player of choice. And if you're watching on YouTube, you can like and subscribe. It also never hurts to tell a friend about us or pop us in a social feed. Maybe if you have a favorite episode, you could share it on a thread somewhere. Thank you again for watching, listening, enjoying, and supporting, and I hope you're all having a great day.